works internally. So here we have map, and the key and value pairs are being stored in this map. So it's a collection. Okay, so string is a key and integer is the value, and we use the put method to assign values. So this is the key, this is the 100 we are assigning. Rahul has 200 marks, Ashish has 300 marks. Okay, so similarly we are passing null here since we can pass. Okay, now let's go to the internal working. So it has around 16 nodes, the hash map. Okay, so based on what the value is here, Naveen is here. Okay, so first of all, for the value, key value, from the key hash will be calculated, and from the hash, for example, the value of hash is something like 211022. Okay, this is the hash value. So we can't, okay, we can directly assign it, but it's a big value, so it will take a lot of space, right? So they've given us index, we calculate from the hash, and whatever the index gets calculated from 0 to 15. Okay, there are 16 nodes. So in each node there is key. Okay, there's value, then there's next, and then there's node. Okay, so that gets stored. So here, and there's hash also. Okay, key value, hash, and the next value, whatever the gets decided, next reference. So here what we do is hash map. So what we here, for example, out of this 4, this we get 4 index. Okay, from this we get 4 index, so it will, this Naveen value will get stored in the, okay, it will get stored in the um, it will get stored here. Okay, first, and then hash will be calculated. Hash, whatever the hash is there, it will get stored here. And then what's the value of Naveen is 100 will get stored here, and this is the next. Okay, next reference, whatever we are giving. Okay, so what happens is, sometimes what happens is when you create another node, so now it comes from here, Rahul has to be assigned to 200. So sometimes hash can be same. Okay, so hash for that can be same. So index can come out as, of course the hash is same, so index will also come out as 4 again. So what happens is, this last is usually null. This is null reference. Okay, but then it refers to the next value. One more node, a set of node gets created. Okay, so what happens is, here Rahul gets stored, and then again this hash gets stored, and then value of Rahul is 200, and again then this comes out as null. Okay, so similarly, when Rahul is there, now Ashish is there, Ashish can come on 7th node. Okay, so similar fashion we can do this. Okay, so similarly we can do it for 7 as well. Okay, but for 7 also we can have the same values, not Rahul but Ashish. Okay, this can be Ashish, and then this value, whatever the new hash would be. Okay, 3 to this hash would be there, and then whatever the Ashish values are 300, so this would get assigned. Okay, so that can happen. And for null it is always 0. The hash is always 0 for null when you assign a null value. So it will always get 0 hash and 0 index, it would get. Okay, what about get? What if I want to, what happens is, after a certain time there's upper limit to this. Okay, before Java 8 1.8, this was like this would always become a linked list of complexity 0 to 0 n. Okay, 0 to the power n. Okay, this is complexity, and then if another value gets stored, so it would again extend this list. This next would come here, and then this would refer to new linked. So this would eventually become a linked list. Okay. So after a certain like eight iterations, after 8 times, certain threshold is there. After that, uh, it converts into a binary tree. Okay, so the complexity becomes O to the log n. Why? Because it is then that time it is more efficient and more fast. So that's why we it becomes so after Java 1.8 it has happened. Now regarding the get method, what if I want to get this value? Okay, marks dot get. Okay, so I can get value of Naveen. So when I print this, okay, there's no value. Okay, I have to print also. So we got 100. How did we get it? Okay, so here also for the Naveen value, it will go to this. Okay, it will calculate the hash of this. So first of all, it will here it will go calculate the hash and index for this. Okay, and it will search for this fourth index. It will go here and search for Naveen first of all. Then it would check for hash value. So it would recognize that this is the one. Okay, again here Tom will be searched. So here it will go, and for example, Rahul has to be searched. So Rahul we'll add Rahul here, and for that hash will be calculated, and here it will calculate go to, and particular index would be calculated. It would go to that particular index and search for Ashish here. Okay, for Rahul what it will do is it will go to that particular index and search for the hash code. Hash code is same, so it would compare the value of key that we passed. Okay, so it would search for that key, and this is not there, so it would go here and search for this key, and it would print out the value using the equals method. We'll use the equal methods there. Okay, so first hash will be calculated and then index will be calculated. Here when what happens is when two values are assigned to the same index, and the next node gets referred by the previous, this is called HashMap collision. Okay, this is the internal working of HashMap. So sometimes in an interview they can ask what is the, for null, what is the hash? So hash would be 0 and index would also be 0. So it will always get stored here in the first index. If we add one more value, so again similar to this will happen. So for binary tree, we know O to the log n will be the binary balance tree. For that, the time complexity would be this much. Okay, that's it.